How does sidereal rate work when aligning a telescope mount? Imagine trying to keep a star perfectly centered in your telescope for hours without it drifting out of view. That's where understanding the sidereal rate becomes so important. When you're setting up a telescope, especially an equatorial mount, you want it to follow the stars as Earth spins. But how does the mount know how fast to turn? That's where the sidereal rate comes into play. The sidereal rate is the speed at which your telescope's motor must rotate to match Earth's rotation. Earth makes a full turn on its axis in about 23 hours, 56 minutes, and 4 seconds. This period is called a sidereal day. Because of this, the stars seem to move across the sky about 4 minutes earlier each night. To keep a star in the same spot in your telescope, the mount needs to rotate at this exact sidereal rate. When you align your mount, the key step is polar alignment. You point the mount's right ascension axis directly at the celestial pole, which is near Polaris in the northern hemisphere. This alignment allows the mount to only rotate around one axis to follow the star's movement. The motor then runs at the sidereal rate, turning the telescope slowly and smoothly to keep the star in view. This process makes long-exposure astrophotography possible without star trails or blurry images. The sidereal rate is about 0.9973 degrees per minute, or roughly 15.41 arcseconds per second. Your mount's motor or clock drive is calibrated to turn at this exact speed. Some advanced mounts have digital encoders or setting circles that measure the position precisely, ensuring the mount stays on track. It's worth noting that atmospheric refraction can slightly change the apparent position of stars, especially near the horizon. Some mounts or guiding software adjust for this by using a slightly modified tracking rate called the King rate. Also, if your polar alignment isn't perfect, stars will drift in declination, which sidereal tracking alone can't fix. That's why techniques like drift alignment are used to fine-tune the mount's polar axis. In the end, understanding and setting the sidereal rate correctly is the backbone of good tracking. It allows your telescope to follow the sky's apparent motions smoothly and accurately. Proper polar alignment and awareness of atmospheric effects help make this process even better. When you get it right, your observations and astrophotography sessions become much more enjoyable and precise.